Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Chemical process design, how to enhance packed column capacity by debottlenecking. In this video course, you will learn how to identify that the existing column has reached its full capacity, what is the need for enhancing packed column capacity, what are the options available for enhancing the existing packed column capacity, a case study on packed column debottlenecking. Please subscribe to the channel. By subscribing, you will motivate us to produce knowledgeable video content for you. So subscribe now before you forget. In the previous video on how to enhance tray column capacity by debottlenecking, I explained how columns can become a constraint to enhance the plant capacity. I discussed the options available for tray column capacity enhancement with a case study. Like tray columns, packed columns can also become a constraint when the plant tries to enhance the capacity or its performance in terms of column efficiency in comparison with the design is not satisfactory. As a result, the product quality does not meet the specification. In either case, the column needs to be debottlenecked to remove the constraint. This video focuses on retrofitting existing packed column to enhance the capacity as a part of process plant revamp. How do you decide that the packed column in operation has reached its full capacity? Once you decide on the quantum of capacity increase needed from the column, rework on the vapor liquid loading on the column in the rectification and stripping section. Use process simulation and do a hydraulic study for the revised vapor liquid loading and observe the following: C factor, pressure drop, and percentage flood. Shown in the figures below are three characteristics of the packing. 1. Pressure drop per unit height of packing versus gas mass velocity or C factor as a function of liquid loading. 2. HETP versus C factor. 3. C factor versus liquid rate at flood for a specific system and column diameter. It is obvious from these figures that as the vapor liquid loading exceeds certain limit, the pressure drop exceeds maximum permissible, HETP increases or efficiency drops, and the column will become unstable. Packed column capacity enhancement alternative options. Let us now move on to find out the alternatives available for packed column capacity enhancement. Enhancement of existing packed column capacity can be achieved in several ways. This needs a strong understanding of the practical design and functioning of packed columns. Through continuous research and development works, packing manufacturers have developed several new packing having 1. Greater surface area, 2. Large void fraction. All methods invariably look to enhancing the packing void or the open area without compromising on efficiency. How do you then go about selecting the packing that can be a candidate for delivering the enhanced capacity? This involves comparing the available packing with the characteristic performance parameters such as packing factor, void, and surface area. These parameters influence the HETP values of the packing. Packed column capacity enhancement, a case study. Now we will walk you through a case study where the existing packed column capacity is increased by 20% in a real world packed column. Problem statement. The epichlorohydrin column is the final product purification column in the epichlorohydrin plant. The crude epichlorohydrin, after being processed in the lightens column to remove the lightens, is fed to the epichlorohydrin column, in which the heavy ends are removed as bottom product and the epichlorohydrin is removed as the distillate product. The column operates in a vacuum of 25 millibar absolute. Cooling water provides the cooling duty at the overhead condenser. The duty at the forced circulation reboiler is provided with high pressure steam. The column is filled with gem-back structured packing. Shown in the figure below is a epichlorohydrin product purification column. The height of the rectification section is 10 meters, that is 2 beds each of 5 meters in height, and there are the stripping section is 2.2 meters. This column, along with many other columns, was facing capacity constraint and needed to be debottlenecked to meet the capacity enhancement objective. Status before revamp. The column was operating at 100% capacity at process loading as per design. The loading and hydraulic data are presented in the table 1 shown next. Shown in the table below is the hydraulic data of ECH product purification column at 100% of the design loading. The capacity factor of packing above the feed is 0.26 feet per second and that below the feed is 0.25 feet per second. You may note that the top of the shipping section has highest percentage flood of 62%. The existing column had some design margin for capacity increase. Hydraulic study was made to ascertain whether the column could be pushed to 120% of the design capacity without any modification, subject to the following design limits. Total pressure drop across the column should not exceed 30 millibar. Maximum percentage flood should not exceed 70. Revamp study. The study indicated that percentage flood in the top of the rectification and stripping sections would exceed the maximum limit of 70. The pressure drop would also exceed the permitted maximum of 30 millibar. Hence, it was concluded that the debottlenecking of the column was necessary to achieve the 20% capacity enhancement on a sustained basis without loss of efficiency. Discussion with the packing vendors threw light on the options available for debottlenecking the column. The most cost-effective solution was to replace the existing gem-back 2A with high-capacity structured packing without compromising on the packing efficiency. Data collected from packing suppliers showed that FlexiPack 250YHC or equivalent structured packing could be a choice. FlexiPack 250YHC is similar in construction to the standard FlexiPack 250Y, except for subtle modification in the geometry of the corrugation at the top and bottom of each packing layer. A comparison of packing characteristics of gem-back 2A, FlexiPack 250Y and FlexiPack 250YHC were made to assess the relative advantages of the latter. This is presented in the table below. It is evident from the table that the FlexiPack 250YHC is better compared to gem-back 2A structured packing in terms of its surface area and packing factor, which will lead to lower pressure drop and higher efficiency, that is lower HETP. It may also be noted that FlexiPack 250Y has almost the same surface area as 250YHC but has higher pressure drop. The hydraulic study of the packing was made at 120% of the original design process loading to assess the capability to handle the enhanced capacity. The results are presented in the table 3 below. The study results showed that the two key criteria of performance of the new packing, which the percentage flood and the pressure drop at the enhanced capacity, would be met at the same packing efficiency. The percentage flood is predicted to be less than or equal to 70, and the total pressure drop across the column will be less than 30 millibar. Based on the study results, it was decided to replace the existing column with FlexiPack 250 by Hesse. The existing reflux redistributors also needed replacement. The capacities of the overhead condenser and the reboiler were checked for the proposed capacity increase and were found to have the required additional capacity. The figure below shows the modifications made in the column. The packing replaced with the higher capacity packing, reflux distributor and redistributors replaced with the higher capacity distributors. Performance after revamp. Upon commissioning, the column with the new high capacity packing performed in line with the project objectives. The column capacity was enhanced to 120% of the original design capacity, permitting the rest of the plant to operate at enhanced capacity. The important hydraulic data of the column after the revamp in comparison with the original column data is presented in the table below. Take some time to understand the data. It is self-explanatory. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.